Okay, in this video I'm going to talk about finding the point at which a line intersects a plane. And the question I'm going to do here is we're going to look at the line that goes through the point 1, 0, 1 and 4, negative 2, 2. And we want to know where that line intersects the plane x plus y plus z equals 6. The basic idea, all you have to do is you first find a parametric representation for the line. And remember to find basically the equation of the line. This is the formula. So you take one of the points on the line and you use the position vector that would point at that line. And then we find the direction vector that would go through the 2 points. Multiply that by t. We can put that together. That'll give us the parametric representation. We then just take each of those. We'll substitute that stuff into our plane equation. We'll solve for t, and then we'll backtrack, and that'll help us find our point of intersection. So what do I mean here by all of this? Well, again, we had our point 1, 0, 1. Let me just label these first. So 1, 0, 1, and we had this point 4, negative 2, positive 2. Okay, so this will be my x naught, my y naught, and my z naught, sorry. This will be my x1, my y1, and my z1. So again, now it's just a matter of plugging all these values into this equation. So x naught is 1, y naught would be 0, our z naught is also 1. We leave the t alone, and then we simply have to subtract them. So I'm going to do this. So we would take 4 minus 1. That would give us 3. We would take negative 2 minus 0. So that'll just give us negative 2. And then we would take 2 minus 1, which would simply give us 1. So let's clean this up, make it look a little bit prettier. Okay, so we could write this again. We distribute the t and then we add respective components. So we would get t times 3, which is 3t. And then if we add the first components, well, we would simply get 1 plus 3t. If we do that for the middle component, we would get negative 2t plus 0, which is simply negative 2t. And then we would get t times 1 plus 1, which would just be t plus 1. So now we have our parametric representation of the line. And remember, the first part is a representation for the x-coordinate. The second part is a representation for the y-coordinate. And the third part is simply a representation for the z-coordinate. Okay, so we've done that. Now we just need to think about our equation of our plane. Well, the equation of the plane that we wanted to intersect was simply x plus y plus z equals 6. And now all we have to do is we simply substitute in our respective x, y, and z values. This will give us an equation involving only t, and then we'll figure out t. So we would get 1 plus 3t plus negative 2t plus t plus 1 equals 6. Okay, so let's see if we can manage the arithmetic here. So 3t minus 2t, that would be 1t. 1t plus t would be 2t. We have 1 plus 1, so that looks like 2 equals 6. And if we simply subtract the 2, we'll get 2t equals 4. Divide by 2, we'll simply get t equals 2. And now all we have to do is simply just backtrack and plug these into our parametric equations. And it says the point of intersection. So the point of intersection, it says the line is going to hit this plane at the value when t equals 2. So if we simply plug that in, that's going to give us the point. Okay, so we would get 1 plus 3 times 2. So I'm just plugging it into the parametric equation. Negative 2 times 2, and then 2 plus 1. Well, we can certainly simplify that down. It looks like it would be 7 -4, and 3. That would be your point of intersection. So again, nothing too crazy here. Fortunately, the equation of a plane is relatively simple, so hopefully the algebra, if you see one of these types of problems, won't be too bad. But again, this is the basic idea. You just need to be able to find the vector equation of a line, and then you're just plugging that into the equation of the plane. Again, that's going to help you find the value for t. Just plug that back into the original respective parametric equations, and that'll give you the point of intersection.